Hi, this is Leandro Durand for the class EEL 6562, Pattern Recognition, and for my final report, I'm going to be talking about facial recognition in OpenCV using hard cascade classifiers. So, the problem under study. In the field of image processing, you have all these kinds of things like object detection, color detection, edge detection, all these different kinds of problems that are tackled by different kinds of algorithms. The main issue that I want to tackle is facial recognition. Not everybody has the same face, so it's not extremely easy to differentiate between people's faces and detect them. Most of the time, what these algorithms end up having to do is to first learn what a face looks like from a training set. So let's say they're given a set of images with people's faces on them, and from there they learn, oh, that's what a face looks like. This later then allows them to take, I guess, quote-unquote, educated guesses about what future faces would look like. So that's the idea of, training an algorithm and with a specific set of training data, where you know what's a face and what's not a face. And then when the algorithm is trained, you can use that for future projects. So there are a couple of really, as I said before, there are many different kinds of different approaches, but I'm only going to talk about 4 of them. One of them, the one that I use, a hard cascade, and then 3 other popular approaches, which are eigenfaces, Fisher faces, and local binary pattern histograms. Both the eigenfaces and the Fisher faces are very math intensive, so they rely on a lot of finding stuff like the mean, the covariance, the relationship between these different numbers, and a lot of statistics. While the local binary pattern histogram relies more, I guess, on the frequency of certain features going off. So you imagine you have like a square of 9 smaller squares inside, and based on what is set off in those different boxes, you have different features, and based on the frequency of how often those things are set off, kind of like, a histogram, which depicts the different frequencies. From there, it can detect what's a feature and what's not a feature. It's all basically done in relation to neighboring pixels. So my approach uses hard cascade classifiers. The idea behind this kind of algorithm is that it uses both positive and negative images. So the idea behind it is the positive and negative images are used as the training data for this algorithm. So the positive images, of course, contain the desired object. So in this case, a face. It could be a ball. Eventually, the algorithm has to figure that out. But the idea is that behind for my project, the positive images have a face, while the negative images do not have a face. So the thing is, to detect these different kinds of features, these different edges in this different objects, this algorithm uses 3 different kinds of feature detectors. The first one being edge detector, which is kind of like a square cut in half, with the black rectangle being where the feature is located, and the white rectangle where the feature is not located. So you kind of have this very big separation between an edge and not an edge, which is helpful for face detection, because you can detect the dip in the color of the images between a face and the background, which is extremely helpful. Another kind of feature detector is a line feature detector, which is similar to an edge feature, except that instead of 2 distinct rectangles, it has 3. 2 white on the sides and a black one in the middle. The black one in the middle allows for the algorithm to detect, the difference between a line and then a feature, or an edge, where the white is the non-line, and so is the other white. Well, the black in the middle is the actual line that was detected. And then the 4th one, which wasn't used very often in my algorithm, or at least in my implementation of it, is the 4 rectangle feature, where you have a black box on the top right edge and the bottom left edge of this square with 4 squares inside. So these are the different kinds of features that are used in this algorithm to find the objects, the desired objects. So the idea is that once you've gone through all these features and in every single pixel, and you've detected what's a face, what's not a face, you've trained all these small little classifiers. So they're kind of weak at first. If you sum them up, you get a really strong classifier. But the idea is that you don't want to use this classifier on every single pixel of every single feature. It would take forever, and it would make the algorithm completely inefficient. So the idea is that you group some of these classifiers into stages. The first stage is more of a general stage, in this case for the object. So instead of checking every pixel for every feature, what you do is you just go through the different pixels, only making them go through the first stages of classifiers. And if these pixels or these windows of pixels don't pass the first stage, then they're thrown out for the next set of classifiers, so they don't even have to worry about them, thereby reducing the number of computations that the algorithm has to go through every single time. So if the algorithm doesn't pass the first stage, then the algorithm's like, okay, that's nowhere near a face, I'm not even going to bother with that next time. Well, if it passes the first stage, the algorithm will be like, maybe that's a face, maybe that's not, maybe it's not, we're not sure. So then the second stage classifiers kick in for the next round, and so on until you get to your last stage, which I guess by that point the algorithm should have a 95% confidence of like, oh yeah, that's a face. So the problem that I wanted to tackle was the idea that sure, you can detect a person's face when looking straight forward, but sometimes the orientation of a person's face can throw an algorithm off. So I wanted to modify this algorithm to detect people's faces while laying down. And well, I had two simple methods that I wanted to try. One very, very straightforward, and another one involved training a new classifier with a new set of positive and negative images. These positive images of people's faces, but under the new condition, lying down, and the negative images holding no faces at all. The other very simple solution was to literally just orient the input images 90 degrees to the right or to the left, just so the algorithm knew what it was dealing with. So these were my results. So this is the original algorithm looking straight forward. It can detect my face in green, and just for redundancy purposes it can detect my eyes in blue. This is the modified algorithm where the input was changed. So as I'm laying down on my bed, this is very simple. Once again, it can now detect the green face, the green what's my face, and the blue what's my eyes. The only issues that I had is that when I ran my own train algorithm, it wasn't as effective. So all in all, what ended up really having the best results was simply just changing the orientation of the input image by 90 degrees. My newly trained algorithm with the classifier, even though it was using a new XML file, with the new training data, with the new positive and negative images, it wasn't able to detect a person's face as efficiently. But for future work, I do want to try to implement negative images with people's faces, or without faces laying down. So having a mixture of the two, where the positive images is both people laying down on the ground, people laying down, and also people like standing up straight, because those are both really technically faces. It's just that the orientation really is what throws the algorithm off, because it uses a lot of the position of each feature to kind of relate to each other, and gets kind of all kinds of complicated. So I have learned a lot from this class, and I plan to use all this knowledge in future projects. I've learned a lot about a new way of thinking, a new way of tackling projects, of just not inputting data, throwing code, and running it through. It's more about just like figuring out what those patterns are and what works in a specific algorithm, not just going straight head on, but analyzing it and really thinking about the patterns that are going on. So yeah, I really enjoyed this class, and I hope you like this presentation. Thank you very much.